Welcome back to the channel. Today we are proving one of the classic circle facts that shows up again and again in geometry. If two tangents are drawn from the same external point, then the two tangent segments are equal. So in our picture, if the tangents from point P touch the circle at A and B, then we want to prove PA equals PB. And before we start, if you enjoy these geometry proof videos, please subscribe, hit like, and leave a comment. That really helps the channel. And honestly, it keeps me motivated to make more of these. Also, this theorem is one of the top 15 circle properties that I think every serious geometry student should know. I linked that full top 15 circle properties video in the description, and I will point to it again in the end scene. Let us do the first proof. We draw the two radii, OA and OB, and we also connect the center O to the external point P. Now look at triangles OAP and OBP. First, they are both right triangles because a radius to a tangent point is perpendicular to the tangent. Second, OA equals OB because they are both radii of the same circle. Third, OP is a common side. In fact, in these two right triangles, it is the hypotenuse for both of them. So now we have a right triangle congruence setup, equal hypotenuse and one equal leg. That is exactly the hypotenuse leg criterion, often called HL. Therefore, triangle OAP is congruent to triangle OBP, and this is worth slowing down for, because the animation here is the geometric heart of the first method. One right triangle flips onto the other because the rigid data already match, a right angle, one equal leg, and the shared hypotenuse. This is why the equal tangents are not a guess. The entire outer picture is being forced by the inner right triangle structure. And once the two triangles are congruent, the corresponding tangent sides must be equal. So PA equals PB. That is the first proof. Very clean, very classical. And if you are solving under time pressure, this is probably the proof you want to see first. But now I want to show you a second proof, because this is where the theorem becomes more memorable. The second proof does not focus on triangle congruence first. Instead, it focuses on angle transfer. So now connect A to B, forming chord AB. Inside the circle, triangle OAB is an isosceles triangle because again OA equals OB as radii. So the base angles are equal. Angle OAB equals angle ABO. Now pause here because this is the hinge of the whole second method. Those two equal angles live inside triangle OAB, but we actually want information about triangle PAB, the outer triangle. So how do we transfer angle information from the inner triangle to the outer one? Tangency does it again. Since OA is perpendicular to PA, angle PAB is complementary to angle OAB. And since OB is perpendicular to PB, angle ABP is complementary to angle ABO. But equal angles have equal complements. So from angle OAB equals angle ABO, we immediately get angle PAB equals angle ABP. And now triangle PAB has two equal base angles. Therefore, triangle PAB is isosceles, which means the opposite sides are equal. So once again, PA equals PB. And that is the second proof. And if you are learning circle geometry seriously, that matters a lot, because the top 15 circle properties are not isolated facts. They form a network. Tangents give right angles. Radii give equal lengths. Equal radii create isosceles triangles. Isosceles triangles create equal angles. Equal angles give you symmetry somewhere else. Once you start seeing that chain, the diagram stops feeling mysterious. That is why this theorem belongs in the top 15 list at all. And this is one of the reasons circle geometry is so beautiful. One rigid picture can support several different chains of logic, and each one reveals something slightly different about the structure. If you want, pause here and try to reconstruct both proofs without looking. That is a very good test of whether the theorem is really in your memory now. Again, this equal tangent theorem is one of the top 15 circle properties every geometry student should know. The full top 15 circle properties video is linked in the description, and I will reference it again in the end scene. We are going to keep making videos on the other circle properties and their proofs in future videos. If you enjoyed this one, please subscribe to the channel, hit like, and tell me in the comments which circle theorem you want next. That really helps me know what to make, and it genuinely keeps me motivated. Thanks for watching, and I will see you in the next proof.